Hello, this video is for textbook chapter 2, lesson 3, so it's lesson 2.3, and the title of this lesson is Simplifying Variable Expressions, where our objective is to, well, just as the title of the lesson states, it is to simplify variable expressions. So we're going to be talking about expressions. We know what those are. They contain numbers and variables. Well, variable expressions do. And addition or subtraction signs. They do not include an equal sign because once you add an equal sign to it, you go from an expression to an equation. Our vocabulary for this lesson are the words are term, coefficient, constant term, and like term. So starting off, it says fitness. You work out each day after school by jogging around a track and swimming laps in a pool. In example 4, you'll see how to write and simplify a variable expression that describes the number of calories you burn. So the next part here you see leading up, we have an image here where we have labels of terms and coefficients, and we see our algebraic expression here. So let's take a look at that. The parts of an expression that are added together are called the terms. So this 5x, 4x, and 7, these are all terms. These are the parts that are being added together. We call those terms. In the expression below, the terms are 5x, 4x, and 7. The coefficient of a term with a variable is the number part of the term. So the ones that have variables such as 5x and 4x, the coefficients are the numbers that we see tied to them. They're related in this case by multiplication. So 5 is being multiplied by x, so 5 is the coefficient of x. Here 4 is being multiplied times x, and 4 is the coefficient of the term x. So the values that are with the variables, the actual number parts, these are known as coefficients. And whenever we write this, it would seem kind of awkward to write this as x5 plus x4 plus 7. That would just seem a little awkward or a little backwards, and backwards would be a really good term for it because we prefer for the number to come first than the variable, such as 5x plus 4x plus 7, as we see here. And the reason for that, and therefore, that is the reason why we refer to the coefficient not only as the coefficient, but as the leading coefficient. So always put your coefficients before the variables. Moving along, a constant term such as 7, here we see the number 7. So what is a constant term? It has a number, but it has no variable. So our terms that have no variables, we call these constants because, well, this is constantly going to be 7. This term here, if x is 1, then it has a value of 5. If x is 5, then it would have a value of 25. You see, the value can change. The value of this term can change, all depending upon the value of the variable x in this case. However, 7 is always going to be 7. It's constantly going to be 7. Therefore, we call it a constant. So a constant term such as 7 has a number, but it has no variable. And the reason we call it a constant is because it's going to consistently be that value. Like terms are terms that have identical variable parts. In the expression above, 5x and 4x are like terms. So the variable part, being x in both of these terms, are like terms because the variable portion of the term are identical. 2 or more constant terms are also considered like terms. So if we had added a plus 6 on here, then 7 and 6 would also be constant terms as well. Well, take that back. They would also be identical terms. So 2 constant terms, 2 or more constant terms are also considered like terms. So on our next page here, we will indeed identify parts of an expression, identify the terms, like terms, coefficients, and constant terms of the expression. So we have to identify terms, like terms, coefficients, and the constant terms. So our solution is to first write the expression as a sum. So we see here that we have, trying to find a line. Yep, I got line lit up. So we have y, and we have 8. And here we have subtraction, right? So let's go ahead and change this subtraction to addition, and then take the opposite of the next value, which is -5. So that's where we get this -5y. And again, we're going to change the subtraction to addition again, and take the opposite of the number that follows it, and that becomes -3. That's because terms are separated by addition and not subtraction. It's just that sometimes, and whenever we simplify things, we go ahead and we write our expressions using subtraction signs, but we need to remember that this is the same as plus a -5y, and this is the same as plus a -3 there. All right, so now that we have written the expression as a sum, we can now identify all of the terms, like terms, coefficients, and constant terms. So our terms, remember, the terms are the parts of the expression that are being added together. So we see 3 plus signs, so we must have 4 terms. And here, indeed, we have 1, 2, 3, 4 terms. Those terms are y, 8, -5y, and -3. And we see those listed here. What are the like terms? Well, remember, like terms, we have to look for identical variable parts. Well, here we have a term of y, and here we have a term of y. So the like terms are y and -5y. And then likewise, we also see a +8 and -3. These are constants. So 8 and -3 are like terms. Moving along, we look for the coefficients. Remember, the coefficient is the value or the number that is sitting out in front of our variables. So in that case, an important thing to note is that y is equal to 1y, because we know that we can go ahead and if we have any number such as 3, that's equal to 1 times 3. Well, the reason we would write this y as 1y is so that we can identify that a variable by itself, without a number in front of it, actually has a value, or a coefficient, and that coefficient is 1. It's like I like to say that every constant, or every variable, has a coefficient, and it just so happens to be that whenever it's a 1, it's the invisible one. Get it? The invisible one. So with that said, it always goes over so much better in class. So coefficients are 1 and -5. Those are the values that are with, remember, you put a 1 here in front of the y, right here. So 1 and -5 are the coefficients. These are the numbers that are related to the constants, in this case through multiplication. Next, we have, what are the constant terms? Well, the constant terms are the numbers without variables, such as 8 and -3. On the next page, we're going to talk about simplifying expressions. So you can use the distributive property to write an expression such as 7x plus 4 as a single term. So here we have 2 terms, but they happen to be like terms. Notice that they're both in terms of x. Note the way that I say that, in terms of x. I describe the term in terms of whatever its variable portion is. So 7x and 4x are both like terms. They are in the terms of x. So through distributive property, we see in this example here, in this expression right here, I'm just looking at this part here. So looking at that, what's in both of them that can be taken out? And that would be the x, right? We could take an x out of both of them. And so then we have the x taken out here. And what's left over? The 7 and the 4. Here's the 7 and the 4. It's an addition sign, so we have an addition sign. So that's how we get from the first portion, or this first expression here becomes this here. Now we can go ahead and do the 7 plus 4, That's 11, and we still have the x, so we would bring that x along with it. So 7x plus 4x is equal to 11x, and we did that through the distributive property that we see here. The like terms 7x and 4x have been combined, and the expression 7x plus 4x has been simplified. A variable expression is simplified if it contains no grouping symbols and all like terms are combined. So 7x and 4x, they were like terms because they have identical variable terms, and so we can combine those and we end up with 11x's. So also we note here a definition for simplify. This is getting kind of crowded here. Let's erase some of that. So we do have a definition here. We've been simplifying for quite some time, but we now see that something is simplified if it meets these conditions, that we have no grouping symbols and all the like terms are combined. So in the first one here, we have 4n minus 7 minus n plus 9. Let's first write it as a sum. That is to say, let's change all the subtraction signs over to addition signs. So we recognize that we have 4n, and now this negative 7, we're going to turn into plus a negative 7, or the minus 7, plus negative 7. The minus n becomes plus negative n, and then with plus 9, we go ahead and bring our plus 9 over. Once we've completed that, we can do the next step. Note that what they've done here is they say commutative property, and what is it that they commuted? It is this negative 7 and the negative n. Notice that between these two lines here, they've exchanged places. And now that they've exchanged places, we can then look at this next line here, and we realize that it looks like we've taken the 4n and the plus the negative n, and we have then, we put in our coefficient of 1. So we just changed this here. We're writing coefficient of negative n as negative 1. So again, just like we put the right here where we put this, I'm trying to write with the line. Right here where we threw the 1 in front of the coefficient y, we do the same thing here and put the negative 1 in there with the n. Actually, the negative was already there, but nonetheless. So let's go ahead and move on. So we have that there. They've done this so that we can recognize that there is a coefficient here, because we're going to go ahead and distribute something out. And we're going to just take out the n. We see the n here. What's left? 4, 4, negative 1, negative 1. It's addition, and we have the addition. So this is through the distributive property. And yes, this is a difficult way of doing it, but on the next page we're going to see, or on an upcoming page, we'll see how there's actually a shortcut for it. So with that said, we distribute that out. Now we can go ahead and do the 4 plus negative 1. Well, that's the same as 4 minus 1, so that's 3. 3 what? The n has to go along for the ride, so we have 3n from this. And then negative 7 plus 9 is going to give us a positive 2. We now have no grouping symbols. All of the like terms are combined, so this expression here is now simplified to 3n plus 2. Looking at our next page, let's go ahead, and it says to identify the terms, like terms, coefficients, and constants. So we'll go ahead and do that. So for our first one, our terms are what's being added together. So we'll list them out: 3x, 2, and 5x. These are our terms. The like terms, so we identify the ones that have identical variable portions. So I would have 3x and 5x, so the like terms are 3x and 5x. And then our coefficients, well, that's the numbers that come in front of the variables, so our coefficients are 3 and 5. And then what are our constants? The constants are the ones without the variables, so the only constant we have is 2. Looking at the next one here, we'll go ahead and erase these. On the next one, our terms are what's being separated by the addition signs. And we have this minus 10, so we're going to change that to plus negative 10. So our terms are negative 7b, the 3 terms of b, and then remember this is not a 10, this is actually a negative 10. So we'll be sure to put that negative sign there. Our like terms, so the ones that have a identical variables. So here we have a negative 7b, and we also have, and I'm going to go ahead and put the 1 in front of that right now because that's going to come in handy whenever we do coefficients. So we realize that b is the same as 1 times b. So the coefficient for this variable b is 1. What are our coefficients? Negative 7 and 1. And what are our constant terms? Oh, like terms. We got a couple more like terms, right? And 3 and negative 10 are also like terms because they are constants. And then what are our constant terms? Our constant terms are 3 and negative 10. And we'll go ahead and do this last one over here. Number 3, it looks like. And for number 3, we have 5 negative, or plus, we have 5. 8w, I saw this negative sign coming up. Change that to addition. Change the next value to the opposite, which is negative 6. Take this subtraction here, change it to addition, and the opposite of w is negative w. So our terms are 5 and 8w. Our other terms are negative 6 and negative w. And now, like terms. First, we'll match up the variables, the ones with variables. So these are both 8w and w are both in the terms of w. So our like terms are 8w and negative w. Also, we have a couple constants. So 5 and negative 6 are also like terms. So 5 and negative 6. Our coefficients, that's the numbers that come in front of the variables. So they are 8. And hopefully you've noticed here that I could put a 1 in front of this w, so negative 1 is going to be a coefficient as well. Boy, hard getting the words out of my mouth today. And then finally our constant terms are 5 and negative 6. So 5 and negative 6. So a little bit of practice there on identifying terms, like terms, coefficients, and constant terms. So a quick way to combine like terms, so this is the shortcut that I was talking about earlier. A quick way to combine like terms containing variables is to add their coefficients mentally, right? So you could do it in your head. You don't have to do the distributive property that we saw before. In example 2, for instance, we had 4n plus negative n equals, and we found out that it equals 3n. Well, that's because 4 plus negative 1 equals 3. And remember, we have a 1 in front of this n. So 4 plus negative 1 equals 3. So this shortcut will be used from now on in the textbook, and it will always be the shortcut that I use as well. I was really having a hard time not telling you in the previous examples, just add the coefficients together. That's a lot easier that way. Don't have to do the distributive property. You see, even distributive properties having a tough time coming out today. So here we're going to distribute the 2 into the x and the negative 4. I have my 9 plus 1 is brought over. That's the same. And so 2 times x is 2x, and 2 times negative 4 is negative 8. On the next step, we're going to simplify this to the next line here by grouping like terms. You'll notice that the negative 8 and the plus 9 have actually changed places. They've just flipped places there. So this is grouping. We've grouped them. The reason that they've done that is so that the 2x and the 9x are next to each other. So you now know to add the 2 plus 9 is 11. And they're both in terms of x. So we bring the x along for the ride. And then negative 8 plus 1 is negative 7. So in the end, we end up with this expression here is equal to this expression here. It is simplified. We have no grouping symbols, and all the like terms have been combined. On the next one, it looks like we have some distributive property here that we need to do. The 8, negative 8, this is a negative 8, so negative 8 to the k is negative 8k, and negative 8 times positive 2 is negative 16. And of course you see the 3k has been brought over as well. Going from this next line, we can now add the 3 to the negative 8, and 3 plus a negative 8 is the same as 3 plus negative 8. So do that little change there and you realize that this is plus a negative 8 instead of minus a positive 8k. So 3 plus negative 8 is negative 5. Negative 5 what? Well, it's in terms of k, so the k has to go along for the ride. And then we bring down the negative 16, and we end up with negative 5k minus 16. And on the last one here, we have to the identity property. It looks like, yeah, they kind of done this the sneaky way. My mind's saying, oh, I got 4a's and I have negative 4a's, and so they're going to cancel each other out, and I'm just going to end up with the 3 here, right? But if you weren't careful, you might think that was a negative 3. So let's go ahead. The way that what they're saying to do is identity property. So you see that this and this is identical. The only thing they've done is they put in the 1 right here in front of the parentheses. That's because identity property, we can multiply anything times 1, and it's equal to itself. So we don't change the value by putting that value of 1 right there. Now through distributive property, we end up with negative 1 times positive 4 is negative 4. Negative 1 times negative 3 is positive 3. So that's where we get this next line. You now see that we add 4 and negative 4 together, we get 0. And then 0 times a would cancel out the a as well. So these two cancel each other out because they are opposites. And all we're left with is the positive 3. So it simplifies down to the answer of 3. So let's go ahead and we'll simplify 2 of these. For the sake of time, we're just going to do 4 and we're going to do 6. So I'm going to distribute this 4 into the quantity of x plus 1. So 4 times x is 4x. 4 times 1 is positive 4. I'm going to bring down my 2x and the plus 5. Now, so that you can see it, they end up having these two switch places. So we have plus 2x plus 4 plus 5. Now we can add 4 plus 2 is 6. 6 what? It's in terms of x, so we need 6x. And then we can also add the 4 plus 5, and that is 9. So simplified, we would end up with 6x plus 9. On number 6 over here, looks like I need to, here's a trick. Instead of that 1 and doing distribute it, there's a couple ways to do this, and I'm conflicted on which way to tell you. You could just watch. We'll do both. First, let's go ahead and put the 1 in like they said. So I would have 8c plus 2, and then negative 1 times c is going to equal a negative 1c, which is 1 times c is c. And negative 1 times 2, right there, negative 1 times 2, is going to be negative 2. Now, if I did this another way, and I just said that, think of this subtraction sign as the opposite, right? Then it's the opposite of everything that's in here. So this positive c becomes a negative c, and the positive 2 becomes a negative 2. Either way, whichever one's easier for you, whatever you think, go ahead and go with that. It looks like I now need to, I'm going to take 8c. I'm going to flip these two here through commutative property minus, and just for the fun of it, I'm going to go and put the 1 there so that we see that the coefficient of c here has a negative 1 in front of it. And then my plus 2 and my minus 2. Actually, let's write this negative 2 as plus negative 2 for now. So now I have 8, and I guess I could have done that in another step just so that we can see this. 8c subtraction, change to addition, take the opposite of negative 1 or positive 1c, it's negative 1c, right? Then plus 2 plus negative 2. Now 8 plus negative 1, which is the same as 8 minus 1, is 7c, and these two, positive 2, negative 2, are opposites, so they'll cancel each other out, giving me just 0, and I just end up with 7c is what that would simplify to. All right, so on the number 4, this is the referring back to the story that we had here at the beginning about the jogging and swimming example. So here we have that done out for us in example 4, and for the sake of time, we're going to kind of run through this. We're at 25 minutes now on this one. So during your workout described on page 78, you spend a total of 45 minutes jogging and swimming. You burn 14 calories per minute when jogging. That's some information, important information there. 14 calories per minute when jogging. So when jogging, and then we'll color code it. 8 calories per minute when swimming. And I think I actually color coded the same as they did down there. I really wasn't even planning it that way. So we're going to let J be the time for jogging. So that's good. Letter J for jogging in minutes. Write an expression in terms of J for the total calories you burn during your workout. The second part would then be, down here B, would be to find the total number of calories burned if you jog for 20 minutes. Notice they just say you do it for 45 minutes, jogging and swimming, but they don't necessarily tell you how long you did one or the other. It's just a combination. So our solution is to first write a verbal model for the total number of calories burned. Well, we know that it's going to be the calories that you burn per minute and how long you jog. So it is 14 calories. Up here we see 14 calories per minute. So that's where the 14 comes from. Jogging time is in terms of J. Then you need the calories that you burn per minute when swimming. So we know that that's 8 calories, so we see 8 there. However, this in parentheses here has to be, it's our swimming time, but we need it in terms of how it relates to jogging. Well, it makes sense that, note that because your entire workout lasts 45 minutes, and your jogging time is in J, then that means that your swimming time must be equal to 45 minus J. That is 45 minutes minus the time you spent jogging would be the amount of time that you were swimming. So this equals that. So that's where they get this 45 minus J comes from, right here. This is your swimming time. Next thing that they did is that they go ahead and they distribute this in right here. We see that 14J carries over here to 14J. 85 times, or 85, 8 times 45 is 360. And 8 times negative J is a negative 8J. Now through the grouping, through commutative property, they've now moved this 8J over by the 14J so that they're closer together. Now 14 minus 8 is 6. 6 what? The J has to go along for the ride. We're combining like terms here. So they're both in terms of J, so we can combine those to 6J and then bring down to 360, and we end up with an expression that uses our jogging time to express the number of calories that we burned. So now we're going to plug in, they tell us that we jogged for 20 minutes. So how many calories did we burn? Well, we jogged for 20 minutes. We would just plug in 20 here, substitute 20 in. So here's our expression. It's carried down to here. We plug in 20. 6 times 20 plus 360 is going to equal 480 calories. And that brings us to our guided practice page. What are terms that have a number but no variable called? So that is like, well, this one here. This is a term that has a number, no variable. Number, no variable. Looks like a number, no variable. Those are called constants. They're constantly that same value. What is the coefficient of y in the expression 8 minus 3y plus 1? Well, we have to remember that this is the same as 8 plus negative 3y plus 1. And so the coefficient of y is the value in front of it. So in this case, that value would be -3. And for the sake of time, we've done a lot of these. We identified constants and terms before on previous examples. We've also done some simplifying expressions. Looking at the error analysis, we look for what is it that they did incorrectly. Well, they bring over the 5a, got the 5a, and then this should be the opposite of, remember, we need to put a 1 in here and distribute in, and that would be a negative times, negative times positive is negative, so the -3a is correct, and then -1 times -7 is not -7, it's +7, so that should have been a +7 there. Another way is, like I said, think of this as the subtraction sign, saying the opposite of, and so this is a +3a, it now becomes a -3a, and this is a -7, and it should have become a +7. All right, so after a nice long discussion of what are terms, coefficients, constant terms, and like terms, how to combine them, the idea of what does it mean to simplify, and a bunch of other stuff, we have learned how to simplify variable expressions, and this lesson, I hope, helps you with your activities.